So I just did number 8 on the study guide, and now I'm going to be going to number 19, which is another double replacement reaction, but it's a little bit different than some of the ones that we've been doing, so I'm going to go over that. So number 19, double replacement. Okay. So for this one, it's one of the ones that you have to predict the products. So it's NH4, NO3, ammonium nitrate, aqueous, plus NaCl, also aqueous, yields. Our ammonium has to replace sodium, so it becomes NH4Cl, plus NaNO3. Now, when you have the double replacement reactions, and you have the two aqueous reactants, you have to look and see whether or not a precipitate will be formed. In this case, no precipitate is being formed because, like I said before, our solubility rules, ammonium and nitrates are always soluble, which means they cannot form a precipitate. So these two are aqueous. It's already balanced. So these two are aqueous, which means no reaction. It's no reaction. So this one is no reaction because both of the products are soluble in water, therefore there is no precipitate. So just nothing happens. So you just can write no reaction. So since that one was really short, I'm gonna go on to another one. I'm gonna do one more double replacement, and it's number 23 on the study guide. So 23, double replacement. Okay. So it's in words, so we have to convert back into chemical formulas and predict the products. So aqueous solutions of potassium bromide, so KBr, aqueous, plus, where am I? Plus silver nitrate, so AgNO3, aqueous as well. And it only gives us the reactants, so now we have to do our replacements. So this becomes our potassium replaces silver, so it becomes AgBr plus potassium nitrate, KNO3. And now we're gonna balance them. Are they already balanced? All right, it's already balanced, so all coefficients of 1. That was easy. So what you do for this one is, since double replacement, both of these are aqueous. Now we have to see if precipitate forms. So according to our rules, group 1A elements and nitrates are soluble in water. Therefore, this will not form a precipitate. Well, really, actually, just forget about that. Really, this compound just will not be the precipitate rather than form precipitate. It just won't be the precipitate. So silver bromide, silver is a metal, and it's not on our list of being soluble unless paired with like a polyatomic, but in this case, AgBr is the solid. So since we know there's a precipitate, we have to do the full ionic and the non-ionic. So full ionic is K plus Br minus plus Ag plus NO3 minus yields AgBr. So the solid stays together, we don't break that up, plus K plus NO3 minus. And again, we cross out on both sides are spectator ions. So potassium and nitrate are just floating around in the solution among the precipitate. And our net ionic is now Ag plus Br minus yields AgBr, the precipitate. So that's all I'm gonna do for double replacement reactions.